We carry powerful computers in our pockets every day, our smartphones. These devices have become an essential part of our daily lives, seamlessly integrating into our routines and connecting us to the world in ways we never imagined possible just a few decades ago. They let us talk to people across the world, bridging distances and bringing loved ones closer no matter where they are. Whether it's a quick text, a voice call, or a video chat, our smartphones keep us connected in real time. We can watch videos, stream our favorite shows, and play games, immersing ourselves in entertainment on the go. From catching up on the latest news to enjoying a moment of relaxation with a game, our smartphones offer endless possibilities. But have you ever stopped to think about what makes all this possible? What is it that powers these tiny devices and enables them to perform such complex tasks with ease? Hidden inside every smartphone is a tiny but mighty component, the printed circuit board or PCB. This unassuming piece of technology is the backbone of our devices, housing all the essential components that make our smartphones function. These intricate green boards are like miniature cities, bustling with electronic components all working together. Each tiny part has a specific role, from processing data to managing power, ensuring that our smartphones operate smoothly and efficiently. Without PCBs, our smartphones would just be lifeless pieces of plastic and metal. The PCB is the heart and brain of the device, orchestrating the symphony of electronic signals that bring our phones to life. They are the unsung heroes of the mobile revolution. These tiny brains inside our phones have transformed the way we live, work, and play, making the impossible possible and turning science fiction into everyday reality. So the next time you pick up your smartphone, take a moment to appreciate the incredible technology inside and the tiny brains that make it all happen. So what exactly is a PCB? A PCB, or printed circuit board, is an essential component in almost every electronic device you use daily. Imagine a thin, flat board made of a non-conductive material, usually green. This board is the backbone of your smartphone, providing the structure and support needed for all the other components. This board acts like the foundation of our smartphone, providing a place for all the other components to live and connect. Without it, the intricate web of connections that make your phone function would be impossible. Think of it like a giant connect-the-dots puzzle. Each dot represents a component, and the lines connecting them are the pathways that allow them to communicate. The PCB has copper pathways etched onto its surface, like the lines connecting the dots. These copper lines are meticulously designed to ensure that electricity flows smoothly and efficiently. These pathways act as electrical roads, allowing electricity to flow between the different components and making them work together. Without these roads, the components would be isolated, unable to communicate or function as a cohesive unit. The assembly of a smartphone is a complex process, and the PCB is at the heart of it all. It ensures that every component, from the processor to the camera, works in harmony. Next time you use your smartphone, take a moment to appreciate the intricate PCB inside. It's the unsung hero that makes all the magic happen, enabling you to stay connected, informed, and entertained. From design to final inspection, the journey of a PCB is a testament to human ingenuity and precision engineering. It's a small component with a big impact, quietly powering our digital lives. Now let's meet the stars of the show, the electronic components. These are the tiny black squares and rectangles you see scattered across the PCB. Each component has a special job. The CPU, or Central Processing Unit, is like the brain of the phone. It handles all the thinking and processing. The memory is where the phone stores all its information like apps, photos, and messages. And the communication modules allow the phone to connect to the internet and make calls. Of course, no phone can function without power. The PCB also houses the battery management system, which ensures the battery charges safely and efficiently. And don't forget about all the amazing sensors that allow our phones to interact with the world around us. The PCB connects the camera, microphone, GPS, and all those other sensors that let us take pictures, record videos, and find our way home. Ever wondered how your phone knows who you are and allows you to make calls? That's where the SIM card comes in. The PCB has a dedicated slot for the SIM card, which contains your unique phone number and other important information. And let's not forget about the audio components. The PCB connects the speaker and microphone, allowing us to listen to music and have conversations with our loved ones. Section 6. The masterminds behind the magic. Designing and manufacturing these intricate PCBs is no easy feat. It takes a team of highly skilled engineers and technicians working together.
Electrical engineers design the circuitry and layout of the PCB.
Materials scientists select the best materials for the job.
And manufacturing experts use specialized equipment to print, assemble, and test these tiny technological marvels.
Section 7. Designing for efficiency and innovation. When designing a mobile phone PCB, engineers face many challenges. They need to make sure the PCB is small enough to fit inside a sleek phone design. They also need to consider power efficiency, so the battery lasts as long as possible. And of course, they need to make sure the PCB can handle all the latest technologies and features that consumers demand. Section 8. From blueprint to reality, building a PCB. In this section, we will take a closer look at the fascinating journey of how a printed circuit board, or PCB, is brought to life from a mere concept to a functional piece of technology. Creating a PCB is a multi-step process that involves both high-tech machinery and meticulous hand assembly. Each step is crucial and requires precision to ensure the final product functions correctly. It all starts with a blueprint, a detailed design of the PCB created using specialized software. Engineers use this software to map out the intricate pathways and connections that will form the backbone of the electronic device. The design is then printed onto a copper-clad board using a photolithography process. This involves coating the board with a light-sensitive material and then exposing it to ultraviolet light through a mask that contains the PCB design. Next, the unwanted copper is etched away, leaving behind the desired circuitry pattern. This etching process is critical as it defines the electrical pathways that will connect various components on the board. Finally, the electronic components are carefully soldered onto the board. This step requires a steady hand and keen attention to detail to ensure each component is correctly placed and securely attached. Once assembled, the finished PCB undergoes rigorous testing in a lab to ensure it meets the highest quality standards. These tests check for electrical functionality, durability, and reliability, ensuring that the PCB will perform flawlessly in its intended application. PCBs are the unsung heroes in countless electronic devices, from smartphones and computers to medical equipment and industrial machinery. Their reliability and performance are paramount, making the meticulous manufacturing process all the more important. Throughout the process, engineers and technicians work closely together, constantly reviewing designs, test results, and making necessary adjustments. This collaborative effort ensures that each PCB not only meets but exceeds industry standards. Once the PCBs pass all quality checks, they are packaged and shipped to various manufacturers who will use them in their products. This marks the end of the PCB's journey from a simple blueprint to a vital component in modern technology. Section 9. The future is connected. PCBs are not just limited to smartphones. They are the backbone of countless electronic devices, from laptops and tablets to cars and airplanes. As technology continues to advance at a rapid pace, PCBs will continue to play a vital role in shaping our world. We can expect to see even smaller, more powerful, and more efficient PCBs in the future, enabling the development of even more amazing devices and technologies.